Okay, welcome back. So last day we did not get through lesson 5, which is our last lesson in the unit, and it was how to solve for radical equations. We also looked at any kind of restrictions on the variable, and for restrictions you just have to look at, okay, what's underneath the radicand, okay, or what is the radicand actually underneath the radical sign, and you just set it equal that it has to be greater than or equal to 0, and then you solve. Okay, so here I think we did this one, but we'll just go quick. So if I'm looking for any restrictions, I only care about what's under the radical sign. Okay, and we talked about how there are no restrictions here because of this odd index. Okay, these ones I do care about because they're even indexes. So this one, we just set x minus 2 greater than or equal to 0. 4x plus 1 greater than or equal to 0. 2 minus 5x greater than or equal to 0. Okay, so that's the first step. Set it equal to or greater than 0, and then solve. So I'm going to add 2, Oopsies. Okay, I'm going to move that 1 over, and then I'm going to divide by 4. I'm going to move that 5x over, divide by 2, and then, yeah, there's no restrictions. Okay, so we did this one yesterday, hence going through it a little bit quicker. Okay, and I think we might have done this part too, actually. It's upside down. We'll just go through it anyway. So, how to use a graphing calculator. y1 would be equal to the x plus 1. y2 is equal to 4. Yeah, we totally did this one. So there's my 4, and then it intersected at 15, I think, which this is a horrible drawing then. Okay, so yeah, we did this one. Intersect. Okay, and so you should be able to do your intersection feature. Okay, if you're not good at it, you have to practice it. Okay, so get on that. And yeah, state the equation. We did that part. We did also start this one. Oh, what did I isolate? Square both sides. It's okay. It's a good review anyway. So let's talk about this one because I feel like we were maybe on that one. Extraneous roots. We'll go through this one again anyway so that you can see it. Okay, so all we'd have to do is move that 3 over. Okay, then we square both sides. Okay, so now when I square a square root, they cancel out. When I square this, okay, that's going to give me x minus 3, which gives me that. Okay, then you're going to move everything over. So x squared, then negative 6x minus x is negative 7x. And then plus 1 is going to be 10. And then we factor and we ask ourselves what multiplies to be 10 that adds to be negative 7. Okay, 5 and 2. And then I just have to make them both negative. So x is equal to 2, x is equal to 5. Okay. And then verifying the solution, I just need to plug in both of those to either side. So for my x is equal to 2 verification, my right side, 3 plus, and that's going to be root 2 minus 1. Okay, and my left side, I'll just work on this. 3 plus 2 minus 1 is 1. Okay, 3 plus 1 is 4, which does not equal my right side. Okay, so then that is not a solution. Okay, if I do my x is equal to 5, my right side, 3, and then 5 minus 1, okay, well that's 4, and then 3 plus that is 5, which then would equal my right side. Okay, so x minus 5, or sorry, x is equal to 5 is my actual solution. Okay, so that's an extraneous root, or an extraneous root is when you've got an answer, but it is not an actual solution. Okay, So what this is saying here, so extraneous roots, actually, sorry, move it up here. In investigation number 2, one of the solutions can be verified, but the other solution cannot. Can you explain why solving a radical equation by squaring both sides of the equation could lead to invalid solution? And that's what we're going to answer down here. And if you remember, when we square something, so technically 2 squared is equal to 4. Negative 2 squared is also equal to 4. So that's where we've got a bit of a discrepancy, which is what it explains right here. Okay? So in general, the process of squaring may lead to extraneous solutions. All right? So it is always necessary to verify if we've got an index of 2. If we've got an index of 3, we actually don't have to worry about any extraneous roots, but I mean, you can go ahead and verify anyway. Okay, so let's look at this. So example 3, complete the following work to determine the extraneous root of x plus 2 is equal to x. So they've done the first step for us. They've squared both sides. That's going to get rid of that. And that, of course, is just going to give me my x squared. So then I'm going to move everything over. Okay, so minus x minus 2. And then I'm going to factor. So I'm asking myself, what multiplies to be negative 2? That adds to be negative 1. Okay, well that's going to be 2 and 1. And I'm going to have to make my 2 negative and my 1 positive. Okay, so then that means my 2 solutions are going to be 2 and negative 1. Right? Those are both equal to 0. Okay, so right there, then you need to verify. So we'll verify x is equal to 2 first, using this. So my left side is 2 plus 2. My right side would just be 2. 2 plus 2 is 4, which of course is 2. So left side is equal to right side. If I'm verifying x is equal to negative 1, okay, that's going to be negative 1 plus 2, which my right side is going to be negative 1. Negative 1 plus 2 is positive 1, and the square root of positive 1 is just 1. Okay, those are not verified. Okay, that does not equal. And did I do something weird here? Negative, verifying. No, I'm good. Okay. All right, so to answer this question, the extraneous root is negative 1. Okay. So I solved, and I verified, and I found an extraneous root. So solving radical equations algebraically, you're basically going to always use these steps. Okay, you're going to isolate the radical term, square both sides, solve, then verify. And these are when we're worried about index 2. Okay, so isolate, radical, square both sides, solve, verify. So for this first one, the radical is already isolated. It's by itself on the left-hand side. So all I need to do is square both sides. So a square root and a square cancels out, and I'm just left with x plus 3, and then 7 squared is 49. Okay, solve the resulting equation means I'm getting x by itself. So then, excuse me, x is equal to 46. Okay, verify. Okay, so then 46 is going to go into here, so my my left side, sorry. 46 plus 3. 46 plus 3 is 49. Square root of 49 is 7, which is equal to left side. Verified. Okay. So now in part B, I don't have my radical by itself. I do need to isolate first, so I need to get that 7 over here. Okay, so first isolate, then I want to square both sides. Okay, now when I square, I mean the whole thing. So when you've got a binomial like this, that means you've got the perfect square again. So x minus 7 times x minus 7. So this is just going to be 49 minus x. Okay, so when I FOIL this out, okay, you would get x squared minus 40 or 14x plus 49. Okay, so you should be able to just FOIL that out. Okay, you can also use that shortcut. Remember, you don't have to write this out if x. That's going to be the formula. It's going to be 2a of that. We've talked about this. You did it in grade 10. Anyway, if you need more practice with this, you need to come see me. There's no time really in this course because we've got so much other stuff to go through. It's just assumed you know how to do this. But if you need help, I will help you. Okay, so let's move everything over to one side here. So that negative x is going to become a plus x. So negative 14x plus x is going to be negative 13x. And then we see, actually, those 49s are going to cancel out. Okay. So then I'm going to factor out an x. There's one solution. There's another solution. So x is equal to 0 and 13, but I'm still going to verify just in case one of those is not a solution. Okay. So now I kind of took up my room here. So I'm going to try to be as organized as possible. So x is equal to 0. So for my left side, right here, so that's going to be 49 minus 0 plus 7. Okay, and then my right side, I'm plugging in 0. So 49 minus 0 is just 49. The square root of 49 is 7. Okay. 7 plus 7 is 14. 14 sure as heck does not equal 0. Okay? So that is an extraneous root. So I'm going to verify x is equal to 13 now. So left side. 49 minus 13 plus 7. And then my right side is 13. Right? Because I would plug that back in. So 49 minus 13 is 36. The square root of 36 is 6. 6 plus 7 is 13. Okay, which matches my right side. So the only solution for this example is x is equal to 13. All right. Okay. So if it's got index 3, okay, we're going to follow these steps. So you still isolate, okay, but before when you squared both sides, okay, well that was for a square root. For a cube root, you've got to cube both sides. Then you do all the same stuff, you solve, etc. Okay? So there won't be any extraneous roots, but you would verify just to make sure that you didn't make a little oopsie. Okay, first step, isolate the radical. So I want this all by itself. I don't want this 5 over here. So I'm going to have 2x minus 7 equals to 5, and that's the cube root. Okay, so now I'm going to cube both sides. That's going to cancel out, so I'm just going to be left with 2x minus 7, and then 5 cubed is 125. So I'm going to add 7, and 125 plus 7 is 132. I'm going to divide by 2, and that's going to give me x is equal to 66, not 64. Okay, then you want to verify. So the cube root, 2 times 66 minus 7, okay, oh, and I should stop that, minus 5, so we're seeing is it equal to the left side, or sorry, the right side, of 0. So 2 times 66 is 132. 132 minus 7 is 125. The cube root of 125 is 5. 5 minus 5 is 0, which is equal to right side. So we're verified. Okay, so that is the lesson. You have the rest of the period to work on this for solving. Tomorrow's quiz, you are going to be doing division of radicals, and you're going to be solving radicals, which algebraically and graphically, so make sure that you can do that. Okay? All right, see you later.